What is a filter context in DAX? Filter context in DAX is a crucial concept that determines the set of data that is considered by a DAX formula when it is evaluated. It consists of the filters that are applied to the data model, which can come from different sources, such as explicit filters, filters applied through DAX functions like filter or calculate. Unlike automatic filters from slicers or reports, you define them within your formulas using functions like filter or calculate. These functions act like a sieve, letting you control exactly which rows of data contribute to your calculations. Implicit filters, filters applied through relationships between tables, slicers, and cross-filtering in Power BI visuals. They are like behind-the-scenes helpers. They automatically filter your data based on selections you make elsewhere in your report. This makes it easy to analyze different slices of your data without needing to write complex formulas. Row context. When a row context is converted into a filter context using functions like related or earlier. Row context refers to calculations happening on a single row at a time. When you use functions like related or earlier, you essentially switch from evaluating each row individually to considering a filtered set of rows based on the current row's values. This allows you to perform calculations that depend on data from other tables or earlier rows within the same table. Now, let me illustrate filter context. Let's assume this table named sales as our example with the following columns: sales amount, region, product category. If you create a measure to calculate total sales, it might look like this. In this report, if you add total sales to a visual and then use slicers or filters to narrow down to a specific region and product category, the total sales measure will only sum the sales amount for the rows that match the selected filters. This dynamic behavior is due to the filter context. How about explicit filter context? Using the calculate function, you can explicitly modify the filter context. The calculate function in DAX changes the context in which a calculation is performed. It takes an expression, like summing sales amounts, and applies one or more filters to it. In this example, the filter sales region equals North America is applied within calculate, which means the sum of sales amounts will only consider rows where the region is North America. Essentially, calculate redefines the data scope for the calculation to focus on specific criteria. The filter in this DAX formula ensures that the sum of the sales amounts is calculated only for the rows where the region is North America. This allows you to get the total sales specifically for North America, excluding data from other regions. What about combining multiple filters? You can combine multiple filters in the calculate function, as you can see in this DAX syntax example. The calculate function allows you to refine your data analysis by combining multiple filters. For example, to find the total sales amount for electronics in North America, you can write a formula like this. Total sales North America electronics equals calculate sum sales amount. Sales region equals North America. Sales product category equals electronics. This formula uses the sum function to aggregate the sales amounts and applies two filters. One to include only sales from the North America region and another to include only sales of electronics. By modifying the filter context in this way, Calculate helps you focus on specific segments of your data, making your analysis more targeted and meaningful. The goal was to calculate total sales for the electronics category within the North America region using the following DAX formula. However, the result of this calculation is identical to the calculation that only filters by region. Reason: in the dataset, all sales data for the North America region are exclusively for the electronics category. Therefore, filtering by both North America and electronics does not further refine the dataset beyond what is already accomplished by filtering by North America alone. The data structure inherently means that any sales data from the North America region is exclusively for the electronics category. Hence, the two DAX formulas produce the same result. So, let's create another example using different data. Let's assume we have this table, and we want to filter out the total amount of rows we sold in the customer state of Texas using the same formula format with some modifications. Let's see the result. The result matches the table as expected. Now, let's proceed with other illustrations using related and earlier data. Row context and filter context. Row context applies to operations that iterate over a table, such as calculated columns or the use of iterator functions, SUMX, AverageX, etc. Row context can be transformed into a filter context using functions like related or earlier. Let's see this, for example, in a calculated column. But first I will explain the syntax. This DAX formula will calculate the sales amount after applying the discount. 1 minus related, discount rates, discount. This calculates the discount factor by subtracting the discount rate from 1. Sales, multiplied by 1 minus related, discount rates, discount. This multiplies the sales amount by the discount factor to get the sales amount after applying the discount. This formula applies the appropriate discount rate to each row based on the product category. Now we're here again in Power BI. I have the sales table and discount rates table with established relationships between the product category and sales table. Now, let's begin to calculate the formula. The sales with discount column is computed by taking the sales amount from the sales table, finding the related discount rate from the discount rates table using the product ID, and applying the discount to get the final sales amount after discount. This approach ensures that the sales amount is accurately adjusted based on the specific discount rate for each product. Now, let's create another demo. This time we'll use earlier functions. This formula calculates the rank of each sale within its product category, using the earlier function to refer to the outer row context. Let's assume that we have the sample data to be used in this demonstration. You can see that the sales rank restarts for each product category, ranking the products within each category based on their sales in descending order. This ensures no gaps in ranking. For example, in the clothing category, product ID 1003 has the highest sales, 150, and therefore the sales rank of 1. Similarly, within the electronics category, product ID 2001 has the highest sales, 300, and the sales rank of 1. Visual interactions. When you use visuals like charts or tables in Power BI, each visual can have its own filter context based on the selections and interactions made by the user. These interactions dynamically change the data displayed in each visual. Summary. Filter context determines which rows are included in the calculation. Explicit filters, applied through DAX functions like calculate or filter. Implicit filters, applied through relationships, slicers, and cross-filtering. Row context, converted into filter context with functions like related or earlier. Understanding filter context is essential for creating accurate and meaningful calculations in DAX, as it allows for dynamic data analysis and reporting based on user interactions.